This video is Chapter 6, Question 1, and we will be looking at a question focusing on the time value of money. Let's take a look at our scenario here. Gold Rose Production plans to make 4 annual deposits of $4,000 each to a special building fund. The fund's assets will be invested in mortgage instruments expected to pay interest at 12% on the fund's balance. Using the appropriate annuity table, determine the amount that will be accumulated in the fund on December 31st, year 4, under each of the following situations. And you see we have 4 questions that we'll be working through. The large variations are going to be on when the deposit is made, whether it be December 31st, year 1 or year 0, and then there's interest compounded annually or quarterly. So we'll look at these questions in more detail as we go through the following slides. Let's just highlight a couple important things here. There's 4 annual deposits of $4,000 for this fund. There's going to be 12% interest paid on the fund balance. We're going to be using annuity tables. And then we want to know what the amount that will be accumulated in the fund on December 31st, year 4, under each of the following situations. And then at the bottom here, you'll see there's a note. January 1st, year 1 is the start date of the 4-year period, which we'll look at in more detail as we do these 4 problems. Our first scenario tells us the first deposit is made on December 31st, year 1, and interest is compounded annually. So let's jump down here and look at this timeline that I've created real quick. So you'll see this is year 0, so say this is when they decide they're going to create this fund. So then right after that we have January 1, year 1, then we go all the way down. We have 12/31 at the end of year 1. That's when they make their first deposit according to the problem. Then they go a whole nother year, then they deposit another $4,000 at 12/31 year 2, and so on and so forth for year 3 and year 4. So that is an ordinary annuity, and if you recall, an ordinary annuity is when you make the deposit at the end of a period rather than at the beginning. At the beginning is an annuity due. So to find out what the total accumulated amount is going to be, we take our annuity amount, which is $4,000, put it right here, and we need to multiply by the future value of an annuity, and we get that from our table here. So you need to know how many periods there are and what the interest rate is. So interest is compounded annually, and it's 12% interest that's being paid. So we know it's 12% interest, and since it's being compounded annually over 4 years, then there's only 4 periods we need to worry about. So if we look at down here, the 4th period at 12% is 4.7793, which is the factor that we will multiply by. We put that in here. And then that's going to tell us what the total accumulated balance will be for this scenario. It's going to be $19,117. And again, this is the future value of an ordinary annuity. Moving on to our second scenario, the first deposit is made on December 31st, year 0, and interest is again compounded annually. So as I mentioned earlier, we have the ordinary annuity or an annuity due. This one is annuity due because the deposit is made on December 31st, year 0. So they don't wait till the end of a period like they did in ordinary annuity. They make the deposit at the beginning of each period. So you can see it's deposited here, and the second time it will be deposited here, here at the beginning each time, and then January 1st again on year 4. So at the beginning of each period. So again, we'll take the $4,000 annuity. We're going to multiply it by the future value of an annuity due. So we have the 12% again because it's compounded annually, and then there's 4 periods. So the factor for that will be 5.3528. So we'll plug that amount in up here. And then if you multiply those together, you're going to get 21,411. Now if you recall our answer to the problem before, with an ordinary annuity was around 19,000, whereas the annuity due is 21,000. That's because we make the deposit earlier, so it has more time to accumulate interest and then compound on top of itself. Moving on to our third question. The first deposit is made on December 31st, year 0, and interest is compounded quarterly. So for this problem, we will use the future value of $1 because interest is compounded quarterly. We'll have different periods left for each deposit. So we'll calculate the future value of each deposit separately based on the number of periods remaining for the interest to accumulate and the deposit to accumulate interest on over time. So let's start with the first deposit. We know the deposit is $4,000. Then we're going to jump down here to the number of periods. So the deposit is made on December 31st, year 0. So it's made at the beginning of the period. So that means it has 4 years to accumulate over. And there's 4 quarters in each year. So we multiply by 4, and that tells us the number of periods is 16. Our interest rate that we'll use to find the future value factor is 3% because we took the 12% annual interest divided by 4 because interest is compound quarterly to get 3% per period. So we jump down to our table, we look at 16, we come over to 3%, and we have 1.60471 as our factor. So we multiply that, and we'll get our future value number for the first deposit, and it's going to be 6,419. We jump to our second deposit. Again, it's $4,000. Come over to our periods. At this point, this deposit is made on January 1 of year 1, so it still has 3 years left to accumulate. So we take 3 years, multiply it by the 4 quarters, we get 12 periods. We look at our table, 12 periods at 3%, 1.42576. When we multiply that, we get 5,703. So we're going to jump to the next slide real quick to do these last two so we can have a bigger view of the table for the smaller periods we're going to have. With our third deposit, we again have 4,000. The number of periods is going to be 8. And we get that from the 2 years we have left times the 4 quarters. So we look for our factor for that. We look at 8 for the number of periods at 3%. It's 1.26677. So you fill that in. And that will give us 5,067. And finally, our fourth deposit, again, it's a $4,000 deposit. We have 4 periods because there's 1 year left when the deposit is made on January 1 of year 4. So 1 year times 4 quarters. We look for that future value factor. 4 at 3%, 1.12551. And when we multiply that, we get 4,502. And now we can add up the future value of each deposit made, and that's going to give us a total accumulated amount. And that's going to equal 21,691. We come to our last question, number 4. The first deposit is made on December 31st, year 0. Interest is compounded annually, and interest earned is withdrawn at the end of each year. So this turns out to be very simple, simply because the interest is taken out at the end of each year. There will be no accumulation on that interest, so it's simply 4,000 in deposits for each year times the 4 years they're doing it. Gives us 16,000. That's going to be the total balance after 4 years. So with that, we've now answered all 4 questions.